Good. So before this, I already teach on the optimum controller setting, right? You dah tahu macam mana nak dapatkan the value of P, I and D. Okay. So with the value of P, I and D, you can come up with the closed loop response lah. You dapatlah satu respon. Okay. So basically kita boleh ini di mana case di mana kalau you dapat the response tu it's not very good, then you need to do a tuning. Instead of like this you dapat, bila you dah masuk controller pun you dapat this kind of response. Ataupun you nak buat performance test on your controller. Contohnya macam you do a set point change ke, you tukar daripada set point 1 tukar kepada set point 5. So that one we call it as a performance test. We want to see whether your controller ni dia boleh react tak untuk any changes we do to the process. We change the set point or we change the disturbance. We input the disturbance. So basically your response akan start to kacau lah kalau kita make some adjustment. So bila your system will react and start to fluctuate ke, oscillate ke, and then we need to tune the PID controller tadi yang you dah dapat previously, yang you calculate, you guna tuning rules, you need to change the PID setting balik dengan you tune the PID value. Okay, so for today we will learn about the PID tuning lah. Okay, so apa yang penting di sini adalah, okay, before we go deeper on PID, I just want to recall back. For the P, normally kita panggil dia proportional band or KC. The gain for the P. For the I is I lah, integral, D for derivative lah. So basically PB is in a percentage unit. And for the I and D, we can use the time units, which is second or minute lah. Okay, for the PB, the range is between 1 to 999%, and I is in between to 1 to 9,999. Same goes to D, but D is starting from 0. So just to remind you, for the PB and I, we cannot get the value of PB and I equal to 0. Why? Okay, PB, the formula is KC is equal to 100 over PB, right? So if the value of PB here is equal to 0, and we will get the infinity value, right, for KC. So that one is not, memang tak boleh, kita kena eliminate lah. It will cause the system to be very unstable and uncontrollable. Same goes to I. I, the formula is 1 over I. Kalau 0 at I part ni, then we will get the infinity value lah. Okay. So now I move to the controller algorithm. Okay. So basically we have two types of controller lah, which is analog controller and also digital controller. So analog controller and digital controller, both normally we will use PI or PID. Okay, but there is some different on the formula je lah. Okay, so what you see here, kalau you ingat lagi, you learn in a CPE622, right? Betul tak? Okay, from 501, you dah pernah tengok tak this formula, these two formula? Atau you rasa this is the new formula?
Tak pernah nampak.
Pernah nampak? Okay, I explain one example lah. Okay, let's say you have a tank filled with water. Okay, there is a feed of water into the tank, And then you need to measure the level of the tank and control the level of the tank. Okay, basically LT is to measure the level of the tank, and then this LT is connected with the LC. So the signal of the LC ni adalah electrical signal lah. Sekejap I betulkan balik. Okay, you ada LC. This LC will connected to the some sort like transducer lah. Transducer ni high to P to change, to convert the signal from the electrical signal from controller to the pneumatic signal. Normally, lastly, we will connect with the valve lah. The valve ni, basically the signal can receive by the valve is a pneumatic signal. Okay, so for the controller, this formula is related to this system lah. For example, like you want to make sure the set point, the level of the tank is 10 meter. So you need to input the set point to the controller punya setting. Set point is equal to 10 meter. Okay, so okay, right now your level transmitter read the level inside the tank is 8 meter. Okay, this 8 meter and 10 meter, okay, we need to calculate the error. The level transmitter dekat sini dia akan send 8 meter. Then level controller will read the set point 10 meter. Level controller will do a comparison and dia akan calculate the error lah. So the error would be 10 meter minus with 8 meter, which is 2 meter lah the error. So from the error, okay, kita kena masuk, kena masuk dalam equation this one. Masuk the value of error with the value of PIND that you calculate before guna tuning rules tu. You masukkan kat sini at PB, this is for the proportional lah. 1/I is for integral, D is for derivative. So when you insert in all the value and then you can calculate the value of MV. So basically the controller here, the function is to compare, calculate the error, and then calculate the value of MV. So after LC obtain the value of MV, it will send the information to the transducer. Okay, normally the value of MV we calculate in terms of percentage. So transducer, the valve cannot read the value of percentage directly. So that's why they akan change dulu the signal that can be read by the valve ni. Normally the signal received by the valve is a pneumatic. Pneumatic signal, dia akan push the valve, the opening or closing of the valve. Sama ada pressure tu high ataupun low untuk buka, tutup the valve. Faham ke?
Faham.
So basically controller ni dia calculate the value of MV so that the controller can send the information to MV, bagi tahu MV to take an action based on the calculation of based on the calculation by the controller. Boleh faham? Boleh ke? Boleh. Okay. So using the analog, normally this one lah, the formula. So 100/PV also equal to KC. Okay, for the digital controller, basically we use the same concept. We have, at first ni kita ada P punya gain, and then I, and then D. Tapi the different is the error. error formula. Kenapa kita buat macam ni for the digital controller? Because digital controller will read the discrete value of error. So kita nampak the error is for E at first original time and then original time minus 1, original time minus 2. So that shows the discrete value of error. Sebab kita nak guna pakai the digital controller. That's the difference lah. Boleh faham?
Boleh.
Okay. So now you can read lah the abbreviation of each of the unknown inside this formula lah. I think you already know lah everything unknown inside here, the meaning of each term tu. Okay. So based on these two equation, which is analog controller and digital controller, we can see the relations of MV toward each of the controller. Okay, let's say you come up with this one lah. MV, the relation of MV toward PB, which is 100 over PB. MV towards integral, which is 1 over I. MV toward derivative. Okay. So basically kita nak study the relationship of MV toward each of the controller lah based on this equation. So you can see from here lah, MV is inversely proportional to PB. Because you can see from the equation, the arrangement like this lah, MV equal to 1 over PB lah. PB ni di bawah, I pun di bawah, D je di atas. Okay. Boleh faham this part?
Boleh, madam.
Boleh.
Boleh Okay. So now, okay, kita try to see the relationship of PB and also the MV. Okay, when the increase of value of PB, it will cause, because it inverse, it will slower the action of MV. That's mean, bukaan dia, dia punya sama ada MV action tu opening or closing. So kalau slower means they close lah. Bukan 100% close. It depends on the signal. How many close and how many open. Okay, so next is when the decrease of PB, it will result on the faster or slower action of MV. Macam mana? A decrease on PB. Kalau PB turun, MV akan
Naik.
Senang je kan?
MV akan naik.
MV akan naik lah kan? Okay, so next relation MV to KC. So MV dengan KC kita boleh tengok daripada equation ni is directly proportional lah MV dengan KC. Okay, so bila KC increase, MV will
Increase.
KC decrease. Decrease also.
Decrease.
Okay. So MV dengan I is inversely proportional based on the equation tadi. So bila I increase, MV akan
Decrease.
okay. I decrease, MV akan
Increase.
increase. So same goes to MV towards D and also MV toward E lah. Dua-dua ni directly proportional. So D increase, MV increase, D decrease, MV decrease. E increase, MV increase, E decrease, MV decrease. Okay, boleh faham yang ni?
Boleh. Boleh.
Good. So now, okay, after we learn about the relationship of MV toward each of the controller. Now we want to learn about the relationship between MV and PV pula. Okay, we have two type of relation lah, which is direct action, direct relation and also inverse relation. Daripada tadi kita boleh tengok based on the equation, inversely or directly proportional. Sekarang ni based on the graph, kita boleh tengok direct relation and inverse relation of PV and MV. Okay, if the MV is increased, okay, for the A, MV increase, the PV also increase, both increase, that's mean direct relation. So this one is direct relation. If MV is increased but the PV is decreased, so this one is inverse relation. Increase yang ni, decrease PV. Okay, boleh faham?
Boleh.
Boleh.
Okay, so next, okay, kita ada satu lagi type which is bila MV decrease, the PV increase. Yang ni decrease, yang ni increase. Yang ni dipanggil
Inverse.
Inverse. Bila MV decrease, PV also decrease. This one is
Direct relation.
okay. So dekat sini kita boleh cakap figure 3.2 2A, a decrease in manipulated variable will result to an increase in process response. So this one is inverse relation yang macam you cakap tadi lah. So figure 3.2 2B shows that a decrease in manipulated variable will result to a decrease in process response. So that one is direct relation. Okay, we try to do the other example, straightforward sahaja. Sebab kita nak tengok relation je sekarang ni. Okay, when the MV is increased, the PV is increased. This one is for the 3.23A.
Direct relation.
Direct relation.
Yes, direct relation. So 3.22B, sorry, this one is 3.23B. So increase of MV, you all tulis sama-sama decrease of PV. So this one is
Inverse relation.
okay. Senang kan? Okay. So that one is a relation that we can evaluate based on the equation. So now we have the other type, which is we have a quick tuning chart. So kita boleh tengok juga daripada tuning chart ni, kalau kita okay, kita boleh tengok the relationship bila you tadi you buat MV increase, PV MV increase, MV decrease. Lepas tu you boleh tengok the result on PB, KC, I, D and E kan. Sekarang ni kita tengok dekat quick tuning chart pula. Okay, let's say you have chart 1 is a chart for the QAD type process response. Ingat lagi tak QAD yang kita lukis tu, yang kita lukis pula, yang I tunjuk dekat you tu, daripada nota tu.
Ingat.
So QAD dia ada slight oscillation kan. So this is a QAD, process response. Okay, you can see this one, this QAD process response, we already insert the controller setting. So the controller that been used for this process is PI or PID lah. So from this response, you can see that the response that you get is not very good lah. You tak dapat the best response macam I cerita hari tu. Yang macam ni. And then when you do a set point changes, basically this response pun akan berubah lah. So the 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 main focus that we want to do here is when there's a system that been installed with the controller, and we want to see the performance for the controller, whether it can react with the change or any unwanted situation happen. Kalau with the change, kita try tukar the set point. So if the set point is been increased from set point 1 to set point 2, so basically this response akan berubah lah, betul tak?
Betul.
So bila dia berubah, normally bila kita tukar je set point, basically the value of P and I yang you calculate before this, PI, PID semua yang you calculate before this sepatutnya berubah lah, betul tak? So you need to tune the value of PI or PID controller that you use for your system, right? Because you already make an adjustment, then you need to change the setting lah. The setting that you do before, yang you calculate based on the tuning rules tu, based on the set point pertama yang you buat. So sekarang ni kita nak tukar set point kedua, and then we tune our P, I and D value. So based on this graph, we can see that, okay, kalau let's say for example like this system, you gonna pakai PID controller. Tadi you dah ada your PID value before this, based on the optimum controller setting yang you calculate before this, you dah ada value PID. And then sekarang ni we do a set point changes, so you need to change the value of P, I and D. Okay, we can see from this graph, if you, the solid black color graph, this one is an original graph. So if with the original value of P, I and D. So if you want to change to tune the value of P, I and D, if you take a lesser value of PV as compared to PBO, basically this graph will shift to the left. Dia akan bergerak ke kiri. Okay, when you use the greater value of PB as compared to the original value of PB, this graph will shift to the right. That one is called as a tuning tau. You tukar value, dia akan berubah. So for the I, if you increase the value of I, this graph will shift to the right also. But if you decrease the value of I, this overshoot, the peak of the graph ni akan menurun. Dia akan jadi lebih rendah lah. Macam ni lah contoh dia. Okay, I tak contoh kat situ, I contoh kat sini First your graph macam ni. And when you change the value of PB, lesser as compared to the original PB, dia akan jadi macam ni lah. Dia pergi lebih ke kiri. Macam tu. Nampak tak? Boleh faham tak? Boleh faham ke?
Boleh, madam.
I tak dengar lah.
Boleh, madam.
Okay. Okay. Tadi I pun ada explain. Okay, then kalau you nak change the value of D. D, kalau you take a greater value of D as compared to D naught yang you calculate before, the graph will shift to the left also. If you use and also bila you use greater value of D, when you increase the value of D from the original value of D, your time, the time between the peak ni akan lagi kecil. That's mean your graph tu bentuk dia akan jadi macam ni lah. D dia akan ke tepi and then peak dia mungkin macam ni. The time between the two peak tu jadi lagi kecil lah. Kalau you change the value of D, tu lagi besar daripada D naught. If you change the value of D lesser than D naught, the graph will shift to the right. Boleh ke?
Boleh.
Okay, now we have the other chart, which is chart 2. Chart 2 is for the overdamp type process response. Okay, so this overdamp type process response using PI or PID controller lah for this one. Okay, so if let's say you want to do a tuning, that's mean you after you when you do a set point changes, you need to change the value of P, I, and D. Okay, so if you for this kind of chart, if you increase the value of PB greater than original value of PB, the graph will move to the right. For the PB lesser than PB naught, the graph will move to the left. So you boleh bayangkan macam ni lah. You imagine like this. If you change the value of PB lesser than PB naught, the graph you will get like this lah. It will move, shift to the left. For the I, if I is lesser than I naught, the graph will increase. They move outward, slightly outward. Same goes to D greater than D naught. Slightly outward lah. Boleh faham?
Boleh.
Boleh, madam.
Okay. So next we have a underdamp type process response. Same goes to previous example, chart 1 and chart 2. We can use PI or PID controller for this response. Okay. So for example, like you use PID controller. Okay, when we do a performance test, we change the set point. You need to change the value of P, I, and D. So if you change the value of PB greater than PB naught, and the graph will move to the right. Dia akan move macam ni lah. Bentuk dia masih sama, tapi dia shift. Okay, for the PB less than PB naught, it will shift to the left. Same goes to D greater than D naught. For the I, if we increase the value of I greater than I naught, this peak will, this shape lah, this process response will move to the right. Macam ni lah, lebih kurang macam ni jugalah. If we use the lesser I, the overshoot ni, the peak ni akan mungkin lagi kecil lah. Like this lah. You imagine like this. Boleh faham?
Boleh, madam.
Okay, good. So now we try to see the tutorial lah on the proportional controller first. Okay. So the figure 3.41 show the closed loop response for the water level control. We do a set point change from SP1 to SP2. So originally the controller setting for PB is 30%. I naught is 15 seconds. So you need to draw the change in process response from SP1 to SP2 if the proportional band PB and I is changed to PB lah. PB is changed to 60%. I is remain the same 15 seconds. So you need to assume that the change in process PV is directly proportional to the manipulated variable. That means this system ni MV and PV is directly proportional. Okay, you get the information. The old value of PV is 30, I is 15, the new is 60%, right? The value of I remain the same, which is 15. So the next step, you need to observe the changing parameter and its direction. So dekat sini we can see that the value of PV is changed, but the value of I is not changed, right? Betul tak? Betul ke?
Betul.
Betul, madam.
So PB yes, I no. So if yes, changing direction is sama ada increasing or decreasing.
Increasing.
Increasing. Sebab apa? So kalau kita refer back, okay, basically the first method we use here is based on the equation 3.1.1. So you see from here, equation 3.1.1, this one. So when the PV is, sorry azan lah, boleh tak kita stop dulu?
Boleh, madam.
Boleh, madam.
You all dengar tak azan?
Belum lagi kat sini.
Dekat sini dah start azan. Kita stop kejap Nanti I sambung.
Okay, madam.
Okay, madam.
Okay. Okay, dah. Okay, so by looking to this graph, okay, kalau kita increase the value of PV, we can see that the direction of PV ni is in an increasing direction kan? Dia makin move forward, betul tak?
Betul.
So directly here we can say that if PV is changed, then the direction is increasing. Okay, so now, okay, we need to relate back with the equation 3.11. 3.11. Yang tadilah. We relate back. When PV is increasing, that's mean MV is relation of PV to MV. If PV increasing, MV akan
Decrease.
decrease lah. That's mean lagi slow lah kan. Okay, you can tick here. Okay, number 4. Okay, you dah tahu MV ni akan, the action is slower. So we need to relate with the PV. Dalam soalan, it's been given that MV is directly proportional to PV. So when MV is slower, the PV also will be
Lower.
yes, slower lah. So for the slower process response, normally the graph would be shift to the Okay, I tunjuk this graph Okay, graph yang ini dan graph yang ini, mana lagi slow? Yang first one ke the second one?
Second one.
Yes, the second one would be slower. Sebab apa? Slower, dia take longer time to reach a set point. So number one is take a shorter time. So that's why kalau kita if the slower action of MV will result in a slower process response. So for the slow process response, the response we obtain is shift to the right. So we can draw dekat sini lah. The PB value ni shift to the right lah. Itu based on the equation. We can evaluate the new process response based on the equation. Boleh faham ke?
Boleh.
Boleh Okay, next we have the other method which is you can use based on quick tuning chart. Okay, you know that the PV value, the new PV value is 60%, I is 15. Okay, from this table, we can see that the change is only at PV. So I know. So the change ni is increasing or decreasing? Increasing, right? You faham tak? Number 2 ni dia nak observe apa sebenarnya? In a simple word, basically, okay, you tengok sekarang ni, your old PB and I is 30 and 15. Okay, now the new one is 60 and 15. You akan nampak 60 je yang PB sahaja yang berubah. I masih lagi remain. So that's why you choose yes for PB, no for I. Okay, from the changing parameter from the value, we can say that the PB value is increased from 30 to 60. So the changing direction is increasing. Faham ke?
Faham.
Okay, number 3. Okay, tadi kita dah tahu the PB value is increased. Kita guna pakai the relation of the equation. But now, we need to use the tuning chart. Okay, so based on the response we have, this one is a chart 1, chart 2 or chart 3. Chart 1, chart 2 or chart 3?
Chart 1.
Chart 1. Okay, sebab bentuk QAD response, right? Okay, so you choose chart 1. Okay, so you need to match step 2 and step 3. So kita tengok bila you guna chart 1, okay, when you increase the value of PB, so the graph tu akan move to the right. Ikut arrow ni. So on the response, so basically yang ni dia dah tolong lukiskan dash line untuk you. Basically, kalau dalam example yang sebetulnya, there is no dash line here. You yang kena lukis. So based on the chart 1 tadi, you can say that bila you increase the value of PB, the chart, the response will move to the right. So you akan dapat this kind of response lah. Okay. So you can take the new process response, shift to the right. So you can draw. You draw balik lah dekat atas ni. Basically dekat dash line ni dia takkan diberi dalam soalan. You yang kena lukis. Based on the concept yang you belajar daripada chart tadi. Chart 1, chart 2 and chart 3. And also from the equation pun you boleh tahu. Boleh faham ke?
Boleh.
Boleh,
madam.
Okay, maybe we try tutorial number 2 and then we stop. Boleh?
Okay, madam.
Boleh.
Okay, so now we have a still water level control. So the original value of PB and I is 60%. So this system using PI controller. So the value of original PB and I is 60% and 15 seconds. So you need to draw a change in process response when you change the value of set point from 1 to set point 2. Okay, the new PB is 120 and 15 seconds. 15 seconds, the integral time is remain the same lah. So the old one is 60 and 15. New is 120 and 15. Betul tak? Okay, so from here kita boleh cakap which one we adjust, PB or I. For PB is?
Yes.
Okay, for I is?
No. No.
So the change of PB is increase or decrease?
Increase.
Apa dia?
Increase.
Increase or decrease? Increase.
Increase.
Increase kan from 60 to 120.
Ha-ha.
Okay. So now, okay, we know that our PB is increased. So using the relationship, 1 over PV equal to MV. So when PB increase, MV would?
Decrease.
So yang
Decrease.
option 1 or option 2? Atas ke bawah?
Option 1.
Yes, option 1 lah.
Option 1.
Okay. So we know that we will get the slower MV action. So slower action of MV will result in faster or slower process. Tengok balik soalan ni ada bagi tak? Slower lah because directly proportional kan? PV directly proportional to MV. So this one. Okay, slower response. Make your response shift to the right or to the left.
To the
To
right.
the right.
To the right.
Right lah. Masa dia akan lebih bertambah lah maksudnya. Sebab slower. If faster response, masa dia lebih kecil. And then the response will shift to the left. Itu je konsep mudah yang you boleh faham. So 60, so kita try to use method number 2 which is based on a quick tuning chart. So the old controller setting is 60 and 15. The new one is 120. I is remain 15. So the change is only on PB. So the change is same as above, increasing. So for this response, we need to use tuning chart 1, 2 or 3.
1.
Yes, 1. Okay. So if we use 1, if we increase the value of PB, what would happen to the response? Increase value of PB.
Shift to the right.
Yes, shift to the right. So inilah shift to the right. So you need to draw. So you draw lah response yang shift to the right, which is this one. Simple kan hari ni punya lesson. Boleh faham?
Boleh.
Boleh.
Okay, good. So Do you have any question?
Tak ada, madam.
Tak ada I think if you don't have any question, maybe we can continue the integral and derivative part next week. Sebab tak sempat dah juga kita nak buat hari ini. Sebab ada banyak lagi example that we need to try. So basically, end of each of the controller, I will show you the summarize apa tu the concept behind of each of the controller. Faham?
Faham, madam.
Okay, so I think we can stop until here. We start our class with Tasbih Farah and Surah Wal-As. Okay, thank you.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Faham.
Thank you, madam.
Welcome.